This is the Solve Log Equations video notes. Essential question, how do you solve a log equation? All right, so log equations or logarithmic equations is your main idea, so write that in the left-hand column. And so we have a little property here. And basically what it's saying is that b just can't be 1 in this. So then log base b of x equals log base b of y if and only if x equals y. So if you have a log equation where you've got the same log on both sides, then that means whatever's inside the logs have to be equal to each other. So for instance, if we had log base 2 of x is equal to log base 2 of 7, well, since it's the same log base, that means that x has to be equal to 7 so that the two sides of the equation come out to be equal. Okay, so this is the easiest of the log equations. So let's look at example 1. So solve and check, show your work. So log base 5 of 4x minus 7 equals log base 5 of x plus 5. So according to that last property that we just talked about, this inside this log has to equal what's inside this log for this to be true. So to solve it, we do 4x minus 7 has to be equal to x plus 5. So you drop the logs, ignore the logs for now, and then you just set what's inside equal. So then we solve for x. So let's see, I'll minus x over. So 3x minus 7 equals 5. Add 7 over. 3x equals 12. 5 by 3. Oops. What? So x equals 4. Now you do need to double check that when you plug this in. So when I plug in 4 here, you can't have a negative inside a log. It just can't happen. So when you plug in 4, 4 times 4 is 16 minus 7. So then we get log base 5 of 16 minus 7, which is 9. And then that'll be equal to log base 5 of 4 plus 5, which is 9. So it checks. It's the same on both sides. And you just check, it also checks because these are not negative 9s, which would be impossible to have a negative inside your log. So x equals 4 is the correct answer. Okay, so if you need to make yourself a note that when you check it and you plug it back in, you got to make sure that it doesn't create a negative number inside, because even if this had said negative 9 equals negative 9, you would have to say no solution because you're not allowed to have a negative inside the log. Okay, so go ahead and pause it and try part B, and then unpause it when you're ready to check. Okay, so for part B, since both sides have log base 4, we ignore log base 4. So the insides have to be equal to each other. So 2x plus 8 has to be equal to 6x minus 12. And now we solve. So I'll subtract 2x first. So 8 equals 4x minus 12. Add 12. 1 equals 4x. Divide by 4. So x equals 5. Again, we need to double check. So when I plug that in to check, that's log base 4 of 2 times 5 is 10 plus 8 is 18. We want to make sure that equals log base 4. 6 times 5 is 30 minus 12 is 18. So it checks. It checks because they're both 18 and because they're both positive numbers inside the log. Because again, remember, if you plug it back in and you get a negative number inside the log, cross that out, and then if that's the only choice, you say no solution. Okay, so that's the easiest kind. When you have the same log on both sides, you just set what's equal, or set what's inside the logs equal to each other and solve. Now, example 2 is different because you only have a log on one side, and then just a regular number on the other side. So our first step is going to be to isolate the log on one side. A lot of times that's done for us, which is great. Like in part A, it's already done. So step 1 was already done because we have log base 4 of 5x minus 1. That's the whole log. So whatever's in the parenthesis is inside the log is equal to 3. So that was done for us. Okay. Step 2 is going to be to change the form, which in this case, this is in log form, so then we need to change it to exponential form. So I put a reminder in your notes about what that looks like, okay? Because this whole chapter, if you know that definition of how to switch from exponential form to log form, then you're good on everything, because we've used it in every day of notes. With the exception of the properties of log. I don't know that we used it there because we used all the properties. Okay, so step 2. I'm going to change this into exponential form. So this is log base 4. So that means 4 is the base of my exponential equation. These two cannot be together. So the 3 is the exponent on 4. And then that's equal to everything that's inside the log, which is 5x minus 1. Okay. So once you isolate the log on one side of the equation, which they already did for us, then we change the form. So change it into exponential form. So our base is 4. These two cannot be together. So 3 is your exponent. And everything inside the log is over here on this side. Then our last step is to solve for the variable. Which we get x by itself. So first let's figure out what's 4 to the third power. 64 equals 5x minus 1. Now let's add 1. So 65 equals 5x. Divide by 5. So x equals 13. Okay, and then you do need to double check that when you plug it in there, when you go back and plug it in, it doesn't make a negative inside the log. So log base 4 of 5 times 13 minus 1 equals 3. 5 times 13 is 65 minus 1 is 64. And when you type this in your calculator, you get 3 equals, get checked. So you're good. X equals 13. Okay. So following these steps, I want you to try part B. So pause, and then when you're ready, you've worked it out and you want to check your answer, then unpause it. Okay, so step 1 was done for you. Oops. Do this color-coded here with my steps. So log base 7, 3x minus 2 is all in the log, equals 2. The log is already isolated, so step 1 was done for you. Okay, step 2, we change the form. So then change it to exponential. So 7 is your base. These can't be together, so 2 is your exponent, and that's equal to everything inside the log, which is in the parentheses, 3x minus 2. Okay, then our last step is to solve for the variable. So 7 squared is 49, equals 3x minus 2. So now we add 2. So 51 equals 3x. Divide by 3. So x equals 17. Okay, so when we plug it back in, log base 7 of 3 times 17 minus 2 equals 2. So that gives us, what is that, 1, 2, 60, 3 times 17, that's 1, that's 51, minus 2 is 49. So log base 7 of 49 equals 2, which we'll check. when you type that in your calculator. So again, you're checking that both sides are going to be equal, but you're also checking that when you plug that number back in, it does not make a negative inside the log, because we're not allowed to have a negative inside the log. So if it did, you would have to get rid of that answer. Okay. All right. Last example 3. So example 3, we're going to use the same steps we did before, where we isolate the log, change the form, and then solve for the variable. But notice here we've got a plus sign with 2 of the same logs on one side. So if it's on the same side and you've got something else on the other side, then you have to combine this into one log. So remember, when we had properties of logs, when you had a plus sign between them, it meant that you take what's inside this log and multiply it with what's inside this log. Okay? So with these, when it looks like example 3, the first thing you have to do is make one log on one side. So in this problem, when there's a plus sign there, so it's both of them are log base 6. And then in the big log base 6, you're supposed to take 3x and times it by the x minus 4. That's what that product property said. And then that still equals 2. So when you've got the same log base 6, and they're both on the same side of the equation, you have to make this one log by using the properties of logs. And the property that had addition here said that you take what's inside each log and multiply them together. So I get this. So that's step 1. Okay, now step 2, we isolate the log, which it's already done here. But I'm still going to put that on here, because you do still need to do that. So that's okay. It's already isolated. So this is actually steps 1 and 2 is already done. Okay, then step 3 is going to be to change the form. So after we isolated the log, we change the form. So it's in log form, so then we change it to exponential form. Okay, so then we have 6 is my base. These aren't together, so 2 is my exponent, and it's going to equal everything inside the log, which I'm going to go ahead and distribute that out. So that would be 3x squared minus 12x, because that's everything that would be inside the log. Okay, so now we have this. So then your last step is going to be to solve for the variable. Okay, so let's go ahead and do that. Let's put this in step 3. We're on step 4. So this is 36 equals 3x squared minus 12x. So remember from Algebra 1 and also Algebra 2a, if you have an x squared, then we need to get a 0 on this side. So then I'm going to minus 36 so that I get 0 equals 3x squared minus 12x minus 36. Now, just so I can make these numbers smaller, is there something I can divide everything by? Well, yes. I can divide everything by 3. Then you have to do it on the other side as well. Well, 0 divided by 3 is just 0, so that's fine. So that now gives me x squared minus 4x minus 12. Okay, now I always think you should try to solve by factoring so that you don't have to use quadratic formula. So this is that method where you want it to multiply to give you negative 12 and add to give you negative 4. So then you think about all the things that multiply to give you negative 12. So you have 3 times 4. Well, even if I did negative 4, 3 plus negative 4 does not give me negative 4. So that's out. Okay, so then I try 6 and 2. 6 times 2, this will work. Negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. And since there's a 1 in front of x squared, then I can just make that my two parentheses. X minus 6 because it was negative 6, and x plus 2 because it was positive 2. So if you set each of those equal to 0, oops, I don't like to write it that way. If I set each parenthesis equal to 0 to solve, add 6, so x equals 6 is one answer, minus 2, x equals negative 2 is another answer. So we do need to check these back in the original. So then let's try 6 first. So if I put that up here, so log base 6 of 3 times 6 plus log base 6 of 3 minus, or I'm sorry, 6 minus 4, tricking 6, that's equal to, well, this gives me log base 6 of 18 plus log base 6 of 2 equals 2. So if I multiply those, because that's what that plus means, we get log base 6 of 36 equals 2. And if you type this in your calculator, you get 2 equals 2, so it checks. So 6 works. So we know 6 works. Now let's try negative 2. So I do log base 6 of 3 times negative 2. I can already stop because that would give me log base 6 of negative 6. And remember, we are not allowed to have a negative inside a log. It's impossible to get a negative inside a log. So then automatically this answer is out. So the only answer that works is x equals 6. Because negative 2, when you plug it back in, will give you a negative number inside the log, which cannot happen. Okay. Okay, so go ahead and pause it, and I want you to try part B, and then unpause it when you're ready to check. Okay, so for part B, they're both logs. So, and with the same base, which remember the invisible base is going to be 10 when they don't put it there. So I'm going to put it in just so we have it for later. And then you're supposed to multiply when you see a plus sign here. So then you're going to do 2x times x minus 5. And then that equals 2. So that's step 1 where you make one log, and that's also step 2 because this is now isolated. This is all by itself on one side. So now let's do change the form. So this is where the 10 comes in handy. You have to know what base it is for the exponential form. So that's going to be 10 to the second power equals, I'm going to go ahead and distribute this, 2x squared minus x. Okay. So now step 4 is we're going to solve for the variable. Okay, so that's going to be 100 equals 2x squared minus 10x. We have a quadratic, so we need to get a 0 on one side, so I'm going to minus 100. So 0 equals 2x squared minus 10x minus 100. We can divide all of these things by 2. Make our number smaller. I don't want to deal with that big number. So I get 0 equals x squared minus 5x minus 50. Okay, so remember when you're multiplying, you're looking for what multiplies to negative 50 and adds to negative 5. Well, what jumps out to me is 10 and 5. Because if I make the 10 negative, negative 10 times 5 is negative 50, and negative 10 plus 5 is negative 5. So then my parentheses will be x minus 10 because it was negative 10, and x plus 5 because it's positive 5. So you set each of those parentheses. How we solve is we set each parenthesis equal to 0. What is going on here? So x minus 10 equals 0, and x plus 5 equals 0. That's how you solve by factoring. So then we would add 10, x plus 10, subtract 5, X equals -5 are our choices. So if I plug 10 in here, 2 times 10 is 20. So I'd get log of 20. 10 minus 5 is 5. So it'd be log of 5 equals 2. So we get log. Then you have to multiply those as 100 equals 2. And if you type in log 10, 2 equals 2 is good. So x equals 10 is an answer. Let's plug in -5. So if I plug in -5 into that first one, I get log of 2 times -5, which would be log of -10. You can stop right there. That cannot happen. You cannot have a negative number inside the log. Oops, I'm sorry. So that one's out. I need to box it. So that is not one of your answers. The only answer then that's valid is x equals 10. So x equals -5 is an extraneous solution. Okay. All right, so copy that down on your exit slip in the left-hand column. That's the equation I want you to solve and check and then show your work. So go ahead and pause it, and then when you're done and ready to check to see if you know you're doing it correctly, go ahead and unpause. Okay, so our first step is to isolate the log, which has already been done for us. Okay. The next thing then is to change the form. Okay, so I need to go, it's in log form, so we have to change it to exponential form. So 2 is the base. These break up, so 5 is the exponent. And then what's inside the log is on its own on one side. Okay, now we solve the variable. So 2 to the 5th is 32 equals x minus 6. So we're going to add 6 over, so x equals 38. So then check log base 2 of 38 minus 6 equals 5. So log base 2 of 32 equals 5. So if you type this in your calculator, you do get 5 equals 5. So it's the right answer, x equals 38. Okay? So really on both of these last 2 days that we did where we solved exponential functions and solved log functions, the steps are the same. You have to isolate the exponential or the log, whatever it is. Then you have to change the form. So if it's an exponential form, you change it to log form. If it's in log form, you change it to exponential form. And then your last step is to solve for x after you move it. So solve it and get it by itself. Okay, so do a repetition and then work on the solving log equations worksheet for practice.